Robert Picardo and Bill Nye here, and today we are joined by Dr. Newton Campbell Jr., an artificial intelligence expert currently working on projects for the NASA Space Network, and a member of the Planetary Society.
Hi guys, thanks for having me on today. And yes, I've been a proud member for about 4 years now.
Oh, that's great. That's great. Newton, let's get right to it. Can we get out of here? Can we get beyond our own solar system?
Well, yes we can, physically, but the reality of interstellar space travel probably looks a bit different than how we imagined it. And some of it does sound like science fiction. But space agencies like NASA and private groups,
Like the Planetary Society.
of course, like the Planetary Society, are looking into how we can send our first explorers to other solar systems.
So the edge of the solar system is blurry. It's a blurry bubble.
A cloud, if you will.
Yes.
Yes. So when we talk about interstellar missions, we're talking about making it outside of what we call the Oort Cloud, at the edge of our solar system.
Past all the cometary material
Yes.
and
Yes, all
distant rocks.
All the debris and all of that. And we need to make it past the Oort Cloud and over to Proxima Centauri, our closest neighbor.
Well, that doesn't sound that hard. You just generate a warp field around your starship, you jump into hyperspace, and bang, you're there.
Oh yeah, piece of cake. No, I wish. I would love to see humans go to another star. But the hard truth is that it's not likely that any of us here will live long enough to see that happen.
Yeah, I mean, that's not bad. It just means that our interstellar missions would have to start now, but they wouldn't be finished in our lifetime. I mean, wouldn't that just be a cool thing to leave to future generations? It'd be kind of a fantastic legacy, yes?
What greater gift to your descendants, our descendants, than the joy of discovery?
Exactly, Robert.
So then, how do we actually get out of our solar system?
Well, first we need to find ways for our spacecraft to go farther and faster than ever before. So really, we have to talk about propulsion.
Newton, if you are talking about solar sails, that is my business.
I am indeed talking about solar sails.
A spacecraft pushed by light.
But Bill, photons have no mass.
That's true, Robert. Photons have no mass, but they are pure energy. They have momentum, so they push things. They push things in space. It's amazing.
And we have solar sail spacecraft that are using that energy, using that momentum right now. But to get a future interstellar spacecraft really moving, we would need to fire a huge bank of lasers into the sail from Earth, propelling it at over 100 million miles an hour.
100 million miles an hour? That's a heck of a speeding ticket. So how long would it take that spacecraft to get to the Proxima Centauri star system?
At that speed, nearly 30 years.
Well, that's not that bad.
Yeah, one mission actually hopes to have a fleet of space sails launched in 2069 to coincide with the 100th anniversary of the Apollo 11 mission.
So people of the future would need a spacecraft that, I mean, not only can make the trip, but has to guide itself, right?
Absolutely, and that's where AI really comes in. Without AI, we won't be capable of controlling these spacecraft once they get too far away from the Earth. We'd be talking about years of a communication delay, because remember, our communications are bounded by the speed of light. The spacecraft have to learn to communicate with each other. They have to depend on each other not only to navigate, but to survive and interpret phenomena that occur out there in the universe using some pretty impressive machine learning techniques.
The stuff that crosses their path, the asteroids or what have you.
Absolutely, they have to learn how to differentiate that stuff from what appears to them as normal, and that is why AI is so important.
So people of the internet, what are you hoping to find out there in deep space? What do you want to know about what goes on beyond our solar system?
Leave us a comment and let us know. And be sure to check out the previous videos in this series for more of us geeking out about space and artificial intelligence.
And if you want to be part of the future, then check out the Intel AI Academy. And of course,
The Planetary Society.
planetary.org, your homepage. You'll find cool info and a community of what I might call like-minded enthusiasts.
Thank you for joining us today, Newton.
Absolutely.
But I have one final question. You really think that a simple dilithium crystal-driven warp drive wouldn't do the trick?
I'm pretty sure, Bob. Pretty sure.
They'd be big dilithium crystals,
Well,
like from Rigel 12.
I have a source.
If you can make them.
He knows a guy.
I have friends that we'll talk about it.